All right, everybody, welcome back. In this video, we are going to continue our discussion of sampling distributions, and we will see a powerful way in which we can interact with these distributions, and that is through simulation. You can imagine in the real world, it's actually very hard to construct a sampling distribution by going out and collecting many samples. Every sample that you collect takes time, it takes energy, oftentimes it takes money, and so it can be quite hard to actually go and perform this repeated sampling. But with the advent of computers and computational technology, it's actually quite easy to simulate a sampling distribution. And we are going to take a look at one major example here. And this is through the website Lock5StatKey. Now, the 5 Locks are 5 statisticians, all with the last name of Lock, who developed a website called StatKey, which is great for teaching statistics and especially for simulating things like sampling distributions. I am just going to look at a single simulated sampling distribution, or a single premise. And I'm actually going to look at what it looks like to take a sampling distribution for a proportion. So I'm going to pivot to this website and we'll take a look through it. I should say, I will look at proportions in this video, but the website also has the opportunity to look at a sampling distribution for a mean or an average. So let's get into it. I'm going to pivot here to my StatKey website. So we see ourselves on the website right now. The StatKey website has a bunch of different options, but down here, see if I can highlight it. Yep, you can see it there. This is where we can click on, this is what we can click on to do a sampling distribution for a mean. And here is what I can click on to simulate a sampling distribution for a proportion. So I'll click on that. Now, what I want to simulate is actually a scenario that we were talking about in a previous video. I want to simulate the situation in which I have a ball pit with lots of colored balls. We have a certain percentage of those balls are blue. I think 60% were blue. And then we draw a sample and see what our sample proportion is. So I'm going to do that right now. I'm going to create a population proportion. So I want to tell StatKey what the population proportion is, namely that 60% of our balls were blue. And I will edit that right here. It might be a little hard to see in the video, but I hit the edit proportion button and our proportion is 0.6, right? 0.60 is a proportion, corresponds to 60% as a percentage. Okay. I also need to identify a sample size, which I can do up near the top. It's automatically set to be 100. Let's just leave it like that for now. So I am primed to simulate the following situation. Again, population proportion is 0.6 or 60%, and sample size is 100. So I'm simulating a scenario in which I go into my ball pit, 60% of the balls are blue. I go into my ball pit, I randomly grab 100 of these balls, and I look to see what proportion of my sample is blue. And let's go ahead and do that. Up here near the top, there are these buttons. One of them is Generate One Sample, and I'll do that now. Okay, I generated a sample, and information about the sample we just generated is over here on the right. You'll see that the sample size was 100, and the count, that is the number of balls in my sample that were blue, is 61. Right, 60% of the balls were blue. I drew 100 balls. I expect to get around 60 balls, in my sample being blue. I draw a sample of size 100, 60% of the population is blue, so I expect roughly 60% of my sample to be blue as well. So around 60 balls. I expect around 60 balls to be blue. In this sample, 61 balls were blue, and that is a sample proportion of 0.61. So I drew, like we could say I drew one more blue ball than was expected. I'll do a few more. So let's draw one more sample. Okay, notice this changed. Now for our sample, 63 was the count. So I drew 100 balls, 63 of them were blue. I'll do one more. Aha, and this one we see that 53 were blue. So that gave us a sample proportion of 0.53. So just by clicking a button, I can simulate drawing a sample. Now, you'll notice in the center of the screen something kind of interesting is happening. And again, it might be hard to see on this video, depending on the resolution. But look across the bottom here. You'll notice that there's this big empty grid, and then across the bottom, 3 different points have appeared. And reading those from left to right, we have a point at 0.53, we have a point at 0.61, and we have a point at 0.63. So these are the 3 sample proportions from the 3 samples that we have drawn so far. If I draw a 4th sample, which I'll do now, notice this sample had a count of 66, a sample proportion of 0.66, and a new point has appeared in our picture for this sample proportion. So what is being created in the big screen is our sampling distribution. We are looking to see how our sample statistics, in this case a proportion, right, the proportion of our samples, we're looking to see how these statistics distribute themselves over repeated sampling. So I've drawn 4 samples and I have 4 data points. Let me quickly draw a few more. So I currently have 4. Let's get up to 5, 6, 7, 8, 9, 10. And now notice I can generate many samples at once. So this button says I can generate 10 samples. And so I'm going to click that, and I currently have 10 samples. So let me go up to 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, I've now generated 100 samples. And let me go ahead and get up to 1,000. I'm going to click on this button to generate them 100 at a time. So I'm currently at 100, and now let's go 200, 300, 400, 5, 6, 7, 800, 900, and 1,000. And notice we have now quickly simulated 1,000 samples. We expect, on average, each sample to have about 60 blue balls out of 100, sample proportion of 0.6. But what you see is that our samples varied a little bit. Many of them, so those here in the middle, many of them had a sample proportion of right around 0.6 or even exactly 0.6. But some of them were more or less. We see that a handful of them even had a sample proportion above 70%, with the absolute biggest sample proportion being 74%. On the other extreme, we saw a number of samples had sample proportions at 50% blue or below, with the absolute lowest being 44%. So one unlucky sample out of our 1,000 only had 44 blue balls out of 100 chosen. But what you see overall is that over the course of 1,000 samples, individual samples could vary, right? From extremes as far as 44% up to 70-some%. But on the whole, the entire distribution is unimodal and pretty symmetric, centered around the 60% that we expected. So that is how we can simulate a sampling distribution for a proportion. Simulating a sampling distribution for a mean is very, very similar. And what we want to explore next is this unimodal and symmetric shape. Does that always happen? When do we expect it to happen? And if we know that the sampling distribution is unimodal and symmetric, what kind of conclusions can we draw? So, thanks so much for watching. See you next time.